Hey, welcome back to my series where I help another YouTuber, Melissa Lucy, pass chemistry. And before we actually get started, make sure you download your free study plan using the link in the description. There you're going to find that, hey, those are the videos you should watch. Those are the resources that I recommend that I know can help you succeed this semester. Once you've downloaded that, let's start. We're going to move on to another concept. And this is where I was talking about where, hey, this is not the same thing as velocity. Like this is frequency and this is just velocity or the speed. So that's going to be really important to understand those differences because of this formula. It's telling us the velocity of a moving electron is related to wavelength. So that's it. This formula is basically just relating velocity or the speed of an electron with our wavelength. So understanding that a lot of this, I'd say, actually, will he give you your mass or has he talked about this just yet?
Mm-mm.
No? Okay. Yeah, you're probably going to talk about this a little bit later. Your mass should be given. So like the mass of an electron should be given, but if it isn't, know it either way. Okay, so this is the mass of an electron measured in kilograms. And then we saw this before with our Planck's constant. And then you're typically finding two things, either your wavelength or your velocity. Everything else you know, because it's a constant. But there is an important unit change here, and it's this. So it's not as ugly as it looks, and it looks ugly, but you would actually change joules to this entire thing. And since it's a one-to-one relationship, like there really isn't much that you have to, I'd say, convert. It's literally just replacing joules with this entire fraction.
Okay.
Okay. So, and the reason for that is, once again, based on the units. Because our mass is in kilograms, that's why we have to have this kilograms here. And then our velocity of an electron, the units is going to be meters divided by seconds, that's where this comes in. So it just helps us be able to cancel everything out to then give us what we're looking for.
Okay.
So that being said, let's actually do a question. So this is saying the speed of an electron is 1.85 times 10 to the 7th meters per second. We have two different parts. We're calculating the wavelength and we're calculating the frequency. So the fact that it said the speed of an electron, what does that actually tell us we have?
What do you mean, like what we're given?
What are we given, and then what are we finding for part A?
We are given 1.85 times 10 to the 7th.
Which is what letter or symbol?
What, the M over S?
Yeah.
Something over second.
So specifically, this is telling us it's the speed of an electron, right?
Yeah.
So this tells us the speed or velocity or V. So that's going to be important to know that, hey, V is equal to the speed of an electron.
Okay.
Or it might say, hey, the velocity of an electron is this. Anytime it gives you either one, speed or velocity, you know it's going to be V.
Okay.
And then that's a huge hint that, hey, I have to use this formula.
Okay.
So I know the formula now. So V is equal to that. And then our formula is this. And we're finding the wavelength. Okay. First things first, you always want to convert everything. So have the appropriate units of whatever we're looking for. So I'll set it up and then I'll show you what I mean. Let's just start off with, where's my formula? Wavelength is equal to, I'm just going to put this like I typically would with Planck's constant and pretend I'm not converting anything just yet, just to show you where everything goes.
Okay.
So 626 times 10 to the negative 34th joules times seconds. And then on the bottom, our mass of an electron, which was this. I hope he gives you that. He may or may not. If you have to know the constants, then probably not.
Okay.
That's the mass of an electron. And then we have our velocity. So 1.85 times 10 to the 7th meters per second. And then now you would see that, okay, well, there's nothing that would cancel out joules. And I know that my answer isn't going to be joules since it's not energy, it's wavelength. So wavelength has to be in meters or nanometers, some sort of meter. So that's why we have to change joules to this entire thing. So all of this. So I literally can just say, like pi to joules and then plug this all in parentheses. But don't get rid of this seconds at the end, because that would be wrong. So it's still joules times seconds, but I'm just replacing the joules with this entire thing. So kilograms times meters squared divided by seconds squared.
Okay, interesting.
And then the last step is just, okay, let's actually we have a couple more steps, but after this, I'm going to actually cancel everything out. So I have kilograms that cancel. I have 1 meter that cancels. And then notice where the seconds come from. There are technically 2 seconds here, right? There's a second here and a second here. And then, where did the rest of it go? Oh. This all cancels, and let me explain why, because it's not easy to see. All right, I'll show this one. So this is technically 1 second squared times a second here, and then all divided by, and then this is 1 over a second, or I can think of seconds to the negative first. Okay, this is probably a lot more math than it's needed, honestly. Like, I know you would just believe me if I told you they all cancel, but I still want to show you where it comes from. So I can start off with just the top, saying that, okay, this second cancels, this second cancels. And then I know, well, seconds to the negative first is the same thing as 1 over a second. That's why all of this would then cancel.
Okay.
Yeah, it's where it comes from. I don't expect you to necessarily need to know that. Probably in Gen Chem 2. Actually, yes, in Gen Chem 2 you will, but for right now, no.
Okay.
If I did all of this, this would give us, next page, 3.9315 times 10 to the negative 11th meters. And let's say this is actually asking us to, actually no, that would be it, except our sig figs. Yeah. How many sig figs would we have?
So do I just say 3, or do I have to actually
You're right.
change that? Okay.
Yeah, just 3. And then the reason why you wouldn't is just because, yeah, it's a 1. You don't round up. So it's just 3.93 times 10 to the negative 11th meters. I'm going to say that's it for this one. Now we'll move on to part B. One sec. Okay, so we know what the actual wavelength is, and that's going to come into play again, since this is the second part of this same question. So I know I am given, or I just found, the overall wavelength. Now I'm trying to find the frequency. So what formula, I know I'm not showing it, but what formula, if you remember, would give me the frequency? So I'm finding frequency, and I'm given that wavelength that we just found.
Is this the one we have to rearrange? Or no?
Yes.
Oh, it is.
Yes. Good.
I don't remember what it was.
That's okay. That's okay. That was close enough. I knew what you meant. So frequency, and that's C divided by the wavelength.
Okay.
And then in this case, we actually don't need to rearrange it because it's already, solving for our frequency, which is what we want. If we were looking for the opposite, if we were looking for the wavelength, then yeah, we'd have to rearrange this.
Okay.
And then, do we have to change anything? Like any units?
Oh, Yeah, we have to put it in nanometers
Why?
because wavelength is in nanometers.
Hold on. So I want you to think of what the formula is. So what we definitely know is C, right? We know what C is. That's 3.00 times 10 to the 8th meters per second.
Mm-hmm.
So I'm going to ask again. Since this is in meters, do we need to change the wavelength?
No, because we want them to cancel. Okay.
Yeah.
Yes, no, but that's a good thing. So typically in the very beginning, when your wavelength is nanometers or anything other than meters, then yes, you have to convert. You have to change it to meters. It at the end, when you're actually like, let's say if you had wavelength or if you had something else and it was in like meters and it asked you for a different unit, then at the end you would convert. But going into it, like when you're actually plugging it into the formula, you want this to be in meters.
Okay.
Cool. So we would plug it into the formula. So frequency are constant of the speed of light, and then the wavelength that we found before. Cool. And then our meters cancel. We're left with seconds to the negative first, which is the measurement or the unit of frequency. And then our answer, we would get 7.63 times 10 to the 18th.
So did you just have to know to put the seconds to the negative first?
So how I got that was here. And then this is, here, let me actually kind of make this easier to see. This is the division symbol, and then this is meters. So this is meters per second, right? Or it's easier to see here. This is meters per second, and then this is that meter that I had before.
Mm-hmm.
So the meters and meters cancel, and then what's still here is a 1. So this would have been 1 divided by seconds.
Okay, yeah, so whenever we bring it around, we have to put it to the negative 1. Okay. It's just that roll. I feel like I'm going to forget that.
Or you can just know that, hey, frequency needs to be in seconds to the negative first, unless they tell you, hey, you know, I want this to actually be in hertz. But typically frequency is seconds to the negative first. Wavelength is either in meters or in nanometers. I would say typically nanometers. And then energy is typically in joules.
Like,
Okay,
knowing
good to
that.
know.
Yeah. Like that's how you typically end, unless they actually tell you. And by end, I mean like the actual unit that you're finding. This is typically what they have. If it changes, they'll actually specify.
Okay, I see.
Okay. How do you feel to try this on your own?
I'll do it. I'll try.
Okay.
Why don't you take some time and practice what you just learned?
The speed of an electron is 2.63 times 10 to the 6. What is the wavelength? All right, here we go. We are given, we need the formula, and fine. We are looking for the wavelength in nanometers. We're given
And what is that?
the speed of an electron.
Right? What letter or symbol is that?
For speed?
Yes.
I don't remember.
So speed is velocity. So V.
Oh, this is where that comes in. Okay.
Yeah.
Right.
And then that tells you what formula you're going to use.
Oh, true. That's important. Wow. Okay. It's like all interpretation with these problems.
I know.
Okay, so we are going to use wait, we're finding wavelength. So we need the one with wavelength. Oh, okay. I think it's this one.
Go for it. Good so far? Yes. And then I realized I didn't put it on there, but I have the mass of an electron, which is m. So that is 9.11. If you want to write that, m is equal to 9.11 times 10 to the negative 31st kilograms. Cool. And then we also know what h is.
Yes. Okay. Okay. Here we go. So it's already in, so I don't have to rearrange the formula because we're looking for wavelength.
Correct.
So that's good. Okay, but I'm probably going to have to do some converting.
Right. And do you remember what type of converting we would do? And if you're not, it's okay. We can plug in and I can show you. I can tell you. I can tell you.
So should I put it in then because I don't see it?
Totally fine.
Okay, let's do that. So let me put H. Because I think it's kind of hard to see until you like write it out.
Right. Good.
Okay.
Okay. So would every single unit cancel out?
No.
No. So what units wouldn't cancel out? So actually, first off, we know wavelength, like at the end of this, we're probably going to get meters and then have to go to nanometers. But what other units would be left behind and wouldn't cancel?
Joules and kilograms.
Perfect. So this is that one where...
Yeah.
Kilojoules?
Yeah.
Oh, yeah.
Actually, no, not kilojoules, not kilojoules. It's the one that has that whole...
I tried to combine both of them. Kilograms and joules.
So one kilojoule, I knew what you meant. I knew what you meant. So that 1 joule is equal to the kilograms times meters squared divided by second squared.
Okay, so do I have to memorize that, do you think?
I'm going to say yes.
Okay.
Yeah, I wish I could say no, but if you have to memorize all the formulas and all the constants, I'm going to say yeah.
Probably, okay. So should I erase this then?
All you have to do is replace the joules with that whole thing of kilograms. Yeah.
I know the second stays, but just making some space.
Perfect.
So, how does that go again?
So it would be, you don't have to put the 1. You would just have to, you remove the joules. Now it's just kilograms. And it's going to be a fraction. So kilograms. And then it should also be on the paper. Yeah. Times meters squared. All divided by second squared. There you go. And now all the seconds cancel. Mm-hmm.
Right, okay. Oh yeah, because that's a 2, so these.
Yes. And same with the kilograms. Kilograms cancel, and we're left with just meters, just a meter or 1 meter.
A meter, okay, yes, I see that. So we just have 1 meter, okay. So now I would just put it in my calculator?
Yes.
All right, let's see if I can do this.
And I know technically it would still give you the same answer even if you didn't change it to joules just because you had a multiple choice. But just in case you eventually get free response, or for someone else who has a free response test, you would be docked points.
Or like on the homework problems.
Right. Yeah, mastering chemistry doesn't joke.
Yeah, they don't. It's so bad. Like you literally get 1 wrong because you forgot 1 sig fig or something and you get it wrong.
Mm-hmm.
Trust me, I have had plenty of years of mastering chemistry.
They have no mercy.
No, there is none. Yeah. Okay.
Please tell me you got this too.
Let's check.
Oh God. What did I
try that again?
All right. Here, let me try this again.
To the 6. Did you multiply the bottom first?
I mean, not first, but I like did it in my calculator where I put the 2 with the parentheses next to each other.
I would say always put like, I wouldn't say an insane amount of parentheses, but like double up on your parentheses because that's like the most common calculator mistake on the bottom. So like you'd put the first number in parentheses divided by like parentheses and then like another set of 2 parentheses inside.
Okay.
Yeah.
So that you recommend doing it like that?
Yes.
Got it. Okay.
Yeah.
Instead of like trying to click the multiplication thing. All right.
Right.
I literally got the same thing.
Huh. Okay. Let me try it. It could be me.
It's probably me. But
Negative 31. 2 points. Try it this way, where just multiply the bottom 2,
okay.
and then write that down, and then divide, and then actually divide.
Okay.
Good. And then that's down on the bottom, and then you're going to divide that by the 6.626.
Okay. To the negative. Oh, that's different.
Yeah.
So on your calculator, the reason why it's giving you a different value is because there isn't enough like parentheses or brackets or any of that, like enough separation. And that happens all the time. Sometimes you might even get like if you've ever wondered why it says syntax error, it's because maybe you have an extra parentheses, like you forgot to do like a closed parentheses, and that's like a syntax error.
Okay.
Just meaning that it can't compute what in the world you're asking to do. So, it's going to look like this on your calculator. So parentheses and then divided by, and I'm going to say like a larger parentheses. So I'll separate it with color.
Oh, well, I don't think I put the first thing in parentheses. So maybe that's why.
Okay.
That could have been part of it. Typically it's the denominator that gets everyone. So I like to put as many like parentheses as I can. So the one in black is basically just showing that what's happening in the middle is multiplication. And then that answer is then entirely being divided by the other one.
I swear, I just put it in again. And I got this 1.91 times 10 to the 3. I can't make this up. Like, and I'm checking it right now. Okay, 6.62. Oh, what? Hold on, I didn't put the 6.
That could have been what?
All right, hold on, let's try. All right, I'm gonna really take my time. I'm gonna put it in just like you said. Times. This should not be this difficult. How to use a calculator.
You know, I should make a video on that.
Yeah, you should make a video. We should do a whole series on how to use a calculator.
I think it would do very well. Thought about it.
2.68 times 10. I swear. Alright, I'm done. I literally keep... Are you serious?
Is it 1 point? You got that again?
Yes! Okay, I am literally... I'm gonna send you a picture. 6.626 times 10 to the negative 34 divided by, all in parentheses, 9.11 times 10 to the negative 31, other parenthesis, 2.63 times 10 to... Yes, I swear. Like, I wish that you could see this right now.
I believe you. Are you putting a multiplication symbol here?
No.
No.
I promise.
No, I believe you. Okay, I'm trying to think why. I know we have different calculators. Because I typically I do the e to the negative. Like the e replaces like this portion, the 10 times 10. So I wonder if that might be a factor. I mean, I'm not a calculator expert, but I speak calculator. That's nerdy.
Should I try it like that then?
You can, yeah.
Just to see? Okay.
Yeah, you remember how to get that e portion, right?
Yeah. It's like second.
You're gonna look for like the double e, like second, and then wherever it shows double e on your calculator.
Oh. Oh, I see it. Yeah, okay. 6 times 10.
I'd even say, I mean, it doesn't really matter on this one, but you can do it here too.
Oh, okay. I didn't, but let's just try it in the...
Just keep going. Let's just try. Yeah.
So I would put 9.11 and then do the e.
Negative, yeah, and then the exponent, negative 31.
Oh, do I have to put the exponent symbol?
What do you mean, like that as a negative? Or no, sorry. You don't have to put that it's an actual exponent. You just put the regular number.
Just put negative 31 next to the e, yeah. Okay. That's what I thought, because with the e, like, you didn't have to do that. Okay. So 2.63. Am I putting the multiply or just putting e?
Just put parentheses. Because, I mean, I'm questioning myself now.
Six. Okay. I got the same thing. 1.91.
Let me redo it, because now I'm really thinking, like, did I just punch it in the calculator wrong? Which would have been hilarious.
But then when I did it the other way, though, I got what you got. 2.77 times 10.
Yeah. Which is honestly what I got. I got that again. Oh. Yeah, I got that again. Hold on. Because this is a problem. This is definitely a problem.
Maybe my calculator is, like, damaged.
It's been doing just fine up until this question. No, I get the same answer each time. You for sure are doing all the same exponents?
If we were FaceTiming right now, I would literally do it for you and show you.
I believe you, but okay. I honestly believe you. That I don't know why, but I typically prefer to avoid calculator errors. This is a great example. Is I typically multiply this out, and then like, yeah, I know it's extra work, and then actually write out the number, like here, whatever number you get, and then divide.
Right.
I add an extra step, but I guarantee that it's right.
That extended time's gonna come in handy. Yes,
it is. So just to check your work, it always helps. What you would end up getting is 2.7655 times 10 to the negative 10th. How many sig figs would we round to this?
Times 10 to the negative 10.
Yes. Did you not get that?
When I did it, I got times 10 to the negative 58. What? Okay, hold on. Let me just ask you this. When you just did the ones on the denominator, what did you get?
Yeah.
Did you get... Okay, tell me what you get.
2.3959 times 10 to the negative 24th.
Did you have 2.39593 times 10 to the negative 24th? Because I have a 3 at the end of mine. I don't know if that would make that much of a difference, but...
Oh, no. Sorry, it would have been 3, yeah. I just stopped. But yeah, it would have been that.
Okay, yeah, that's what I got. All right, so let me go ahead and... That's what I got when I did the denominators, and then I put the top in. 6 point... divided by Oh. Yeah, I got it now. Oh my gosh.
Okay.
I am so sorry.
It's okay. We got it. This is a perfect example. I would rather like make these mistakes now and not on the exam.
I just feel so bad. Like, we literally just spent like, but still, I still don't know why initially when I put it in.
I honestly don't know why either. I still think it could be the parentheses. But just in case, I would say, multiply the denominator first, then separate it.
Okay.
Cool. So this question you would have gotten 276.55. Oh, sorry. Convert it. So here, let's switch back to your screen and we'll finish this question.
So it's to the negative. Oh, well, I have to rewrite this whole thing now.
Right. And then we have to convert to nanometers.
Okay. Do you want to just give me that number? I put it in too many times. I can't do it again.
Save me from my misery. Yes, it was 2.765. And then times 10 to the negative 10th meters.
Okay, and we're just putting it in nanometers?
Yes.
Oh my gosh.
Good.
I better get this.
You will. You will. We're practicing now, and I know I gave you a good amount to practice.
I feel like this isn't right.
That's right.
Oh my god.
Or actually, hold on.
No, it should have been... No, that is right. That is right. 10 to the negative first, nanometers, yeah. And then, what would we round this? How many sig figs?
We would make it 2.77.
Good.
Just... Cool. That's it. We're done with this question.
So
You're
glad.
like, be gone. I'm done with this question.
Literally.
I really hope you are learning so much with this series. Comment below and let me know how you're doing in chemistry so far. If you need any more help, you know where to find me, here and my website, melissamaribel.com. Now, I'll see you in the next video.